so 3 part 2 was y equals e to the power of x minus 1 all to be squared. This is the chain rule, girls, okay? So the chain rule is you differentiate the bracket, as in you bring down the power in front of the bracket, inside the bracket stays exactly the same, and you reduce the power in the bracket by 1, so it goes down to the power of 1. And then you differentiate inside the bracket, so differentiating e to the power of x, you get e to the power of x, and differentiating minus 1, you get 0. Right? Okay, so I don't know how it was written. Was it written as 2 to the power of e to the power of x, e to the power of x minus 1, or did they simplify it even further? It was like that, yeah, that's fine. Okay, is that alright? Okay, so that was the chain rule. Bring the power down in front of the bracket, bracket stays exactly the same, reduce the power in the bracket by 1, then you differentiate inside the bracket. Okay, 4 part 2.
Yes. You know when you're like differentiating inside the bracket, but you know how to differentiate.
You sure?
Yeah, but you not multiply the x by the e. No.
You can multiply into the bracket, is it?
No, like you bring down the x with the e. No, you wouldn't.
No. Differentiate, the rule is differentiate e to the power of x, you get e to the power of x.
Oh, yeah.
It's a different rule. It's not the chain rule anymore, it's differentiating exponential functions. There's a separate rule. Is that okay? Right. 4 part 2. Right, okay. So 4 part 2 says y is equal to, well, it says t, but it doesn't really matter. E to the power of 2x all over x. They can call it whatever they want. I'd say that's a typo. Yeah. Right, so you let u equal to whatever is above the line, e to the power of 2x. It's the quotient rule. V is equal to what's below the line, which is x. Right, differentiate above the line. You call it du dx. So you get e to the power of the exact same thing, and then you differentiate the power. So differentiate 2x, you get 2. Here, dv dx is equal to the number in front of x, which is just 1. Right, the quotient rule is v times du dx minus u times dv dx, right, all over v to b squared. Okay, so that would be v, which is x, multiplied by du dx, which is 2 e to the power of 2x, e to the, yeah, right, minus u is e to the power of 2x, multiplied by dv dx, which is 1, all over v to b squared, which is x to b squared. Okay, I don't know how much simplifying they do at the back of the book, but this is fine. Right, okay, is that alright? Are we okay with that? Quotient rule. Okay, so as we move on, you can see everything gets muddled in together. Okay, so we think we're differentiating trigonometric functions and there's a product rule inside it. We're differentiating e to the power of, and there's trigonometry inside it. Okay, so they all get muddled in together. Okay, and that's how it will be. Okay, right. I want to move on to the last section. Right, okay, and then I'm going to muddle everything in together, and we'll do lots of practice on them all muddled in together. Okay, so differentiating log functions, and I hope you remember your rules of logs. Stop laughing. I'll just put log functions on, not writing out the whole word, because I'll probably spell it wrong anyway. And the rule in the log table says that if you have ln x, right, if y is equal to ln x dy dx, remember ln x is log to the base e, right, remember that means log to the base e of x. So log to the base e and ln are the exact same thing. When you differentiate, you get 1 over x, right? So this is the rule in the log tables. So, okay. Example 1. Y equals log to the base e, which is another way of saying ln 5x. Okay, find dy dx is the question. So dy dx. So when you differentiate ln x, you get 1 over whatever it was. So ln 5x, you get 1 over 5x. Is that right? But now, what have I to multiply by? Guess. It's always the same. What do I multiply by? 5. Then you have to differentiate this bit. Okay, so you have to differentiate 5x and you get 5. So simplifying that, the 5's cancel and you're just left with 1 over x. So if you differentiate ln 5x, you get 1 over x. Okay, so you get 1 over whatever the ln is of. So you get 1 over whatever the ln is of, and then you differentiate that. Okay, like we have been doing with the e to the power of, with the signs, with the causes, whatever, right? Okay, you follow the rule and then you differentiate the x term that you're talking about. Okay, example 2. Y equals ln of sin x. So ln of sin x. So dy dx. The rule says what will I get? What will I get? 1 over sin x. Right? But then you have to differentiate the sin x. Differentiate sin x and you get cos x. So my answer is just cos x over sin x. You can simplify that further, but that's trigonometry, so that's the answer. Okay? No. Right, because that's like what would that be like? Because that's not x, that's cos of x, right? And sine of x. So if you cancel the x's, you're just left with 2 words over each other, which doesn't make sense. Okay? Right, example 3. Y equals x, I'll go a bit harder, x squared ln 3x. Well, what do I do with this? Product rule, excellent. So you let u equal to x squared, v is equal to ln 3x, differentiate u, call it du dx. So when I differentiate x squared, what will I get? 2x. Differentiate v and call it dv dx. So what will I get? 1 over 3x multiplied by 3, which simplifies to just 1 over x, because the 3 at the top and the 3 at the bottom cancel. Right, okay, so product rule, it's u times, so dy dx is equal to, I'm not writing out the product rule, okay, but it's u times, which is x squared, times dv dx, which is 1 over x, plus v times, which is ln 3x, multiplied by du dx, which is 2x. Okay, you could simplify that if you want, you don't have to, but it's just I'm spotting here that there's an x squared on top, there's an x on the bottom, so one of those cancels, you're just left with x there. And here, I'll just stick the 2x before it, ln 3x. But you know, you don't have to simplify them, right? You get no marks for simplifying. They normally give you full marks if you get to here. Is that okay? Unless they say the word simplify. Okay?
So if you got to the third line and then you were...
Yeah, if you got to here and the question said differentiate, it didn't say simplify, right? You get full marks.
So, but what if you did simplify anyway?
If you did simplify and you got it wrong, they'll ignore your mistake. If this line written down, you get full marks. They ignore extra work, right? Even if the extra work is wrong, they'll ignore it. Okay? But if they said simplify and you didn't, you would lose marks, obviously. Right? Okay, are we good? Example 4. So I go harder. So we go y equals ln 2x plus 1 all over 1 minus 3x. Now, there's a couple of ways of doing it, but the best way to do it is to apply the rules of logs, right? This is the log of a quotient of a fraction, isn't it? Of a division. Does anyone remember? You can write that as what? ln 2x plus 1 minus ln 1 minus 3x. Rules of logs, if you have a fraction, it's the top, take away the log at the top, take away log at the bottom. If it was a multiply, remember it's the log of the first term plus the log of the second term. Do you remember our rules of logs? Okay, so to differentiate here, then it's easier to differentiate. You could differentiate 1 over 2x plus 1 all over 1 minus 3x and then use the quotient rule to differentiate that, but it's a lot of work. This is the easiest way to do it. Okay, so you get 1 all over 2x plus 1 and then you multiply that by what? 2, because I'm differentiating that. Then it's minus 1 all over 1 minus 3x multiplied by what? Minus 3. Okay, I'm just going to go, that's 2 all over 2x plus 1, and a minus by minus is a plus, that's 3 all over 1 minus 3x. Is that okay? That's your answer. And I'm going to do one more example. Can I move it up? Sorry, have I cut people off? Example 5. So ln of y is equal to x squared plus 4 all to be squared. Right, again, I need to simplify it with the rules of logs before I start. Does anyone remember what I do with that power? Bring it down in front. So you can write that as, that's the same as writing 2 times ln x squared plus 4. Right? So I can go straight away and differentiate the constant at the front. As long as there's no x in it, you don't need to use the product rule, as in that 2 will stay as a 2. Right, so if it's just a constant, there's no variable in it, there's no x in it. So you can just differentiate dy dx equals, I'll put that 2 here, multiplied by 1 all over x squared plus 4, multiplied by, now differentiate that and you get 2x. So that would be 4x all over x squared plus 4. Is that okay? So rules of logs, if there's a power, bring the power down in front, right? Okay, and then differentiate. And a constant, if there was an x in that, you'd have to use the product rule. But because there's no x in it, it's not going to change things, so you can just leave it out in front. Is that alright? But if that was 2x, you would have to use the product rule. Yes?
If the square in the question was cubed, would you have to leave the bracket as squared? Like, you know, people
No, because the rules of log say you'd bring that, if that was a 3, you'd bring the 3 down in front, and that would just be a 3 then. Is that okay? Yeah, no, because it's not the chain rule, because you're bringing the power down in front. You could, yeah, there's a long-winded way to do it with the chain rule, but that's the easiest thing to do, is to apply your rules of logs before you start. Right? Okay? Will I give you your homework and leave you off, because I think I've... Right, so what we'll do is we'll go back to page 295 to 296. And we're going to do 5 up to 10. I'll put up the pictures now in a minute. And then on the log ones, we're going to do page 298. And wait, not to figure out which ones. Let's do 5 to 10 again, right? Okay, except number 8, because I think I did that as an example. Is that right? So the same numbers on each page, but except number 8, because I picked that as one of my examples. Right? Okay, I'll stick up a photo now. Is it time to go home? Is it? Right, okay. I better stop recording.